In this video, we want to evaluate this integral here that involves a rational expression for the integrand. If you want to give this a try, go ahead and pause the video. I'll be right back. So this one has the look of what you would use partial fractions. Let's see if we can factor the denominator first. The degree of the numerator is less than the degree of the denominator. So we take out an x out of this, have x to the third, it's 4x squared plus 4x plus 16. And we look at this group here and this group here. I'm going to use grouping for this one. So here for these two terms here, I can take out an x squared, leave it with an x plus 4. And the second group here, 4x plus 16, I can take out a 4. I get 4 times x plus 4. And you can see you have a common factor here of x plus 4. So we can bring that out. We have x, take out the x plus 4, have another factor then of x plus 4. So taking out the x plus 4 in the parentheses, we're left then with x squared plus 4. So those are the three factors for this one. So the setup for this one then, if we use the partial fraction decomposition here, we have two linear factors. So one factor would be the integral here, some constant a over the first factor, and it doesn't matter in what order we put these, but a over x plus b. Another linear factor is x plus 4, then plus. Now the next one's an irreducible quadratic. X squared plus 4 doesn't factor over the real numbers, so this one we need degree 1 at least, depending on these constants here. So this would be a cx plus d over x squared plus 4. The main thing for this one, of course, is finding the constants here in this decomposition, because a constant over x is going to be easy to integrate. A constant again over x plus 4 linear expression, easy to integrate. And we'll see what we come up with the second one. So this is what we have. Factored it out. This is the setup. So I'm going to delete this for now. So let's go down. So I wouldn't make the video so long. This is the setup we have. Okay, same thing. This is the integrand here, and then this is the setup I just showed you here. And then in this step right here, all we did here was multiply through by the LCD here, which is x times x plus 4 times x squared plus 2. So basically what happens is this denominator cancels out to 1. So I just have the numerator over 1. And though this is what we have right here. And there's several ways you can find the constants. One way is to simply multiply all this mess out and then take the coefficients of the cubic term, and those have to equal to the coefficient of the cubic term on the left. So if you put together all the terms that have x cubed and set that coefficient equal to the left side, that has to equal to -1. All the terms that have an x squared have to equal to, the sum of that have to equal to 13. The constant has to equal to 48. And of course there's no x term, so whatever coefficients the x term has on the right side, that has to equate to 0. That's one way to do it. And then you have a system of equations, 4 equations and 4 unknowns. But you can also do this. Since this actually forms an identity, I can just pick values for x here. So notice here, if I let x equal to 0, what do I get on the left side? Put a 0 where the x is, I get 48. left side is 48. Put a 0 over x on the right side. So notice any term that has an x by itself, product there is going to cancel. So an x there, so 0 there cancels this expression. This has an x there, 0 there cancels that expression. And then right here, 0 here for this one, and 0 for this one. This will give me a 4, and a 0 there is a 4. So that's 16. So basically then I got 16. A is equal to 48. Tells me that A equals to 3. That's how I get this one here. Now for the next one, I want to, again, make it convenient here. So I notice any term that has a negative by x plus 4 factor, if I replace the x by negative 4, that's going to be canceled out. So notice here, if I let x equal to negative 4, this has an x plus 4. So this gets wiped out. Over here, got an x plus 4, so negative 4 there wipes out all of this. So all I'm left is with this right here. So put a negative 4 where the x is here. So this is going to be negative 4 squared is 16 and 4 is 20. And then we got x again, negative 4. That's a negative 80b right here. Divide negative 80 into the right and left side of this equation, 320 equal to negative 80b. And I get b equal to negative 4. And then the same way you can pick x to be 0 and plug into the left side and the right side, and use the fact that you know a equal to 3. Okay, use the fact that you know a equal to 3 and b equal to negative 4. You get this equation. Let x equal to negative 1, again using the fact that a is 3 and b is negative 4. You get this equation. And then you solve these two equations for c and d. If you add these up, c, d and negative d cancel. C and c is 2c. And 1 and negative 1 is 0. So I get c equal to 0. Then you replace the c by 0 in any one of these equations. So you pick it in the first one, put a 0 there, d equal to 1. Or put a 0 here, I get negative d equal to negative 1. So d is equal to 1. So I have all the constants. Okay, just to save a little time there, because that's the tedious part of these types of problems, going through and solving or doing the algebra to get the constants. So now once you have that, you can come back over here then. Say this is equal to the integral of, and then again, a was 3, so it's 3 over x. And then for the next one, I had b over in the next factor. B was negative 4. That's what we got. So this is negative 4 over x plus 4. And for the irreducible quadratic, I get c to be 0, d to be 1. So this is 1. And the factor was x squared plus 4. And we have 3 integrals. I could break this up into 3 integrals, but this one's pretty straightforward once you have the constants. Again, you can do a u substitution for these first two, but you don't really need it, because if you let u equal to, say in the first one, x, du would be the derivative of x, which is 1, so this would be dx. So this would just give you the integral of constant 3. You can just factor that out, 1 over u, and that has a integral of natural log of absolute u. So what we can do here is just say the integral of 3 over x would be 3 times the natural log of absolute u. In the same way, I could let u equal to x plus 4, but du then would be dx, the same sort of thing. So again, for this one, you can just put down the minus 4 as the factor, and that's the natural log of x plus 4. Natural log of absolute x plus 4. And now for this one here, this one is in the form. It's one of your main formulas for leading to inverse trig functions. So the formula we'll be using is one that says the integral of du over a squared plus u squared is equal to 1 over whatever a is, and this is going to be arc tan of u over a. Plus your constant of integration. So I just put a plus 10 here, a plus here, and then I'll move this down over here, and then this will be arc tan, or tangent inverse, and the coefficient here would be 1 over a. Well, in our case, this is a, and this is your u here, u squared. So a is 2 in this case, so this would be 1 over 2. And then arctan of u, in this case u is x, over a is 2, plus the constant of integration. So the final answer then is 3 natural log of absolute u minus 4 natural log of absolute x plus 4 plus 1/2 arctan of x over 2, put this in parentheses here, plus the constant of integration. Thanks for watching. We'll see you next time.